what? So reviewing, if you have a lead coefficient of 1, you could just come up with your two binomials. You want a product of 2, that constant, and you want a sum of the coefficient of the middle term. So that's basically what we're doing, and you figured out 1 and 2. Okay, good. Now let's look at another problem. I want to see what you do on this problem. This is still review. X minus 4, x plus 6. What do you notice about this problem already? It's been factored. Good. How do you know it's been factored? Because it is a... What does factoring mean? It's been changed, or it is a multiplication problem. I have this binomial times that binomial. Okay, so I'm not asking you to factor it. I'm asking you to multiply it. So multiply it out. I want to see what you get. This is review of chapter 7, our last chapter. So multiply it out. You're basically using FOIL, which is horizontal, vertical, and tabular. So what are the first terms multiplied going to get me? X squared. What are the outer terms going to get me? 6x. The inner terms and the last terms. And then if I combine like terms, make it proper, x squared plus 2x minus 24. That would be your answer right here for this problem if I said to multiply. Okay, look at this. Look at this, guys. We came up with the two binomials, like I gave those to you, and then you come up with a trinomial. Work backwards. What's the lead coefficient of this trinomial? 1. So I have to come up with two binomials where these two numbers multiply to get me negative 24, and they add up to be, positive 2. So what's negative 4 times 6? What's negative 4 plus 6? So does it work? So you see how you can go backwards? Okay. If you're like, no, I can't. Oh, well, you'll get to that point soon. All right, now we're going to get to the actual lesson. We're going to start dealing with trinomials that do not have a lead coefficient of 1. So our first one, I'm going to put here factor to make it clear in your notes of what you're doing. Factor 7x squared plus 22x plus 3. Okay, and then I put this in my notes to help you out. This number right here, the LC is not equal to 1, right? The LC is not equal to 1. It's something other than 1. So we can't just go through our process from lesson 8-2. We can't just do the same thing. But there are similarities, thankfully. There are similarities. Okay, there is a shortcut that I want to go over. Actually, there are a few shortcuts that I want to go over second hour today. But I'm going to go through the longer process, which is more sure. And you have to know that process for other problems anyway. So I'm not just making you do a long process and then here's a shortcut, never look at the long process again. The long process is necessary. Okay, so I'm going to still come up with two binomials, but they're not going to start with x and x. They can't just start with x and x because what's x times x? That's not 7x squared, right? Okay, so here's what the process is. And I call it the bridge method, but you can call it whatever you want. Okay, I'm going to multiply the lead coefficient by the constant. I'm going to multiply the lead coefficient by the constant, and I'll write it over here because this is where I have space. What is that product? What's 7 times 3? So I want to get a product of 21, positive 21. And I want to look for two numbers that get me a sum of the middle coefficient, 22. So you see the similarity there? Other than multiplying those two, everything else is the same. All right, can you give me two numbers that multiply to give me positive 21 that add up to be 22? I multiplied these two together, 7 and 3. That's how I got that magic number 21. 21 and 1? All right, 21 and 1. What were some other possibilities? Again, I want you to think of other possibilities. Okay, you could have said negative 21 and negative 1. What's another possibility? 7 and 3, and negative 7 and negative 3. Good. And I know the other possibilities don't work. We get that, but you need to be thinking about those because sometimes you get stuck. You're like, but that doesn't work. But are there others? Oh, yeah, Oh, wait, there are 4 of them in this problem. All right, what's 21 plus 1? 22. That's our magic number. This one's the one that's going to work. But let's say you didn't come up with that originally. What's negative 21 plus negative 1? Negative 22. You see how you're close? Okay, what's 7 times 3? Or 7 plus 3? That's 10. And that's negative 10. So you can kind of see if I get these two first, that's the number I get. I'm not close. I got to think of something else. So that's the thought process. All right, anyway, you're not done. Just because you found the 2 numbers that multiply to give me 21 that add up to be 22, you're not done with this problem. It's actually a longer process. Okay, here's what I'm going to do. I'm going to rewrite this trinomial and see if you can follow what I did. So you rewrite it too. What did I leave out?
22x.
The 22x. Okay. I'm going to put it back in a different form. Okay, I'm going to put it back in a different form. Did I really put it back in there?
Yes.
Okay, look at this right here. Well, what did 22x break down into? 21x and 1x. Where did I get those 2 numbers? Right here. This is where I got those numbers. And you're like, why would anyone want to do that? You just made a trinomial into a 4-term polynomial. Okay, but watch what happens. This is the cool part. Any questions on the legitimacy of this from that? Any questions like, can you do that? Can you do that, guys? Can you do that? Yeah, I could say 5x is 2x and 3x. I could do that. So there's no question on that other than you could do 20 plus 2, and you could put 20x plus 2x, but then it's not going to work after that. So that's why we had to go through this process to find out what those 2 special numbers were. So 21 and 1. Could you have done 1x and 21x? Could you have switched those up? Absolutely. Okay? So you could do either one. All right, now this is what I want you to do. I have 4 terms, but I'm going to group them in a special way. I'm going to group them in a special way. I'm going to group these 2 together and those 2 together. So underline those 2. And this is review of 8-1. Okay, look at these 2 terms right here, the first 2 terms. Is there a GCF of these 2 terms? Just look at the 2 terms. 7x. They both have 7 in them, and they both have an x in them. 7x. But what was left inside the parentheses if I'm factoring this right here? Basically, I'm factoring it. So what's left here in the blanks? 7x times what equals 7x squared? X. 7x times what equals 21x? Okay, I'm going to stay here because I don't want people to get lost. What's the GCF of these 2 terms? We said it was 7x, right? Okay, if I factored these 2 terms, I should be left with this right here. 7x times x? 7x times 3? Okay, good. Guess what I have to do with the other 2 terms? Find the GCF. Does anyone know what the GCF between 1x and 3 is?
1.
1. Specifically, positive 1. I'm going to factor this out right here. You're like, how can you factor it out? What would be left in parentheses? X plus, someone said it? 3. There you go. Whew. Almost done, guys. Almost done. I like this process because it can become automatic. It just takes time. Okay. I factored these 2, and I factored these 2 here, right? I got those 2 factorings. What do they both have in common? Okay, they have an x plus 3 in common. This right here has an x plus 3 in common, and this right here has an x plus 3. I'm going to factor again, and this is where people get thrown off, but here's what I get. What do they both have in common? X plus 3. Right, they both have in common. I'm factoring another x plus 3. What was left behind?
7x and 1.
7x plus 1. That was left behind. Done. Oh, it fit on one screen. That's good. There it is. That's the factoring. There is a shortcut this afternoon. I'll let you guys know. But yes, sir?
This is going to take forever.
She just said there's
Like-
a shortcut, Drew.
But sorry, what's your definition of forever? 3 minutes. Okay, how about we get it down to 2 minutes and 30 seconds? Okay, tough crowd here.
shortcut isn't always best, so
Yeah, and this is good, and you're going to have to use it for other problems. Yeah, definitely. Yes, sir.
I don't understand why you multiply the 7 and 3.
Yes, that 7 and 3, we're going to use to get these two numbers right here because you want to come up with factors. Like you want to be able to come up with factors. So 7 and 3 get multiplied, and then I want to come up with factors of that number. Factors of that. Any of those. I know it's kind of tricky, but you do need to do that. All right, let's do it again.
So Mr. A,
Yes, sir.
are we going to use factors, trinomials, lead coefficient in 12th grade?
Oh, yes. And here's what happens. And it depends because some of you will be calc, pre-calc, statistics even. But you're going to use that. It's going to be a little part out of the whole problem. I mean that. They're going to say, find the line of best fit or factor this graph this quadratic. And factoring is a small part of that whole problem. So, yeah. But you'll get quick at it. You really will. Even these. I'll show you.
Question about the last problem.
Yep.
So when you get the 7x and then for instance x plus 3, how'd you like me to do the 7x on the outside instead of just like 7 and x squared and then?
Yes, because you wanted to get the GCF. So if you just took out a 7 here, you would be left with x squared and 3x, but you didn't get the GCF out. And the goal really is, and actually good question, William, the goal is in the parentheses, you want to have the same thing in the first as you do in the second. You notice x plus 3, that's a good thing. You want to make that happen. And sometimes you're going to force it to happen. Okay, good. Thank you for asking that. Okay, here's another one. 9y squared plus 30y minus 11. Okay, notice, and I'll put here on the side, the LC does not equal 1. So we're not doing our normal thing. Yes, sir?
Don't you have to multiply the 2?
Yeah, I'm just describing it here. Okay, so you don't just get two binomials and then call it quits. No, the lead coefficient is not 1. So I'm going to use this bridge method. So my first step, multiply the lead coefficient by the constant. So what's the lead coefficient times the constant?
Negative 99.
Okay, negative 99. So I got to get two numbers that get a product of negative 99. Does anyone know what the sum has to be? 30. Good. Same. That part is similar to what you did before. By the way, you did this first step on the other problems. Write that down real quick, and I'm gonna. You did it here. What's 1 times 2? Remember you did the lead coefficient. Well, what's 1 times 2? It's 2. But you don't have to say that because it's always going to be that number. So you did that. All right. Okay, anyway. You can get lost in all the numbers, but just throw out some numbers that might be good guesses. Now, here's a little hint. If you have a product of a negative number, one number has to be positive and one has to be negative, right? In order to get a negative whatever. So just throw out a guess. I'm going to throw out negative 1 and positive 99. Okay, right? I mean, that would get me negative 98, but what does that add up to be? Oh, so yeah, positive 98. Okay, that is not 30. That's not what I want. Should I try positive 1, negative 99? No, because it's going to be negative 98, so it doesn't really help. Throw out another one.
30 times negative 30.
Yeah, it's so fun. We got to kind of beat around the bush there. Okay, what if I did?
I was going to do like 11 times 9.
Okay, yeah, you could do 11 times 9. You could do negative 30. Even here, you're getting there. Negative 30, excuse me. Oh, I'm so close. Change the signs. Positive 30. That's what I wanted. So here's the winner. And I want to encourage you right now. Sometimes you'll get it the first time. Soon you'll get it. You'll find those two numbers automatically. You'll think maybe just one. Got them. It just takes time. It's not right away. Those are the two. Okay. But what I'm going to do now is I'm going to rewrite this trinomial, 9y squared, and then negative 11. Notice I leave a gap. What am I going to put in these two spots? I know it's one big spot, but we're actually going to fill it with two.
33x.
Uh-huh. Or 33y. Good.
Y.
I know, that threw us off.
Minus 3y.
Positive 33y minus 3y. Good. Yeah, that's it. Did you have to put the 33y first and then the negative 3y second? No. You could have switched it up. Doesn't matter. It's the fun. That's the cool part. Fun part? I don't know. Yeah, cool part. Okay. Now I'm going to do what we call factoring by grouping. I'm going to take the first two terms and the second two terms and factor those individually. So what's the GCF of the first two? What's the GCF? Daniel, what do you think?
Oh, 9y.
Close.
Oh, 3y.
3y. Okay, 3 goes into both numbers. That's the highest number. And y goes into both of them. That's the highest. What's left in the parentheses? Jack? Angel? What's left here? 3y plus 11. I check it real quick. What's 3y times 3y? 9y squared. What's 3y times 11? 33y. So that works. That's good. Second two terms. They are both negative. What's the GCF of the second two? Negative. Okay, good. I think I heard it from many people. Negative 1. What's left behind? 3y plus 11. Yeah, and remember, William, your question? How do I know I did it right? You pretty much did it right when these two now are the exact same. That's good.
What if I got a different answer, but they're both the same? Like, I did the 33y and then the negative 3y switched the other way?
Yes. Wait, these two?
Yes.
Yeah, you end up with the same thing. What happens is, okay, this is what happens. I'm trying to picture it. Did the 3y minus 1 go in here? And then the 3y and the positive 11 are here?
Yes.
Yeah, cool. So it works out. Okay, you take whatever's in the parentheses. You see how these both have these in? Wow. I have these two now. And what do they have in common? 3y plus 11. So I'm going to take that out. 3y plus 11. What was left behind? 3y minus 3y minus 1. So, William, you probably got 3y minus 1 times 3y plus 11. Same thing, thankfully. Oh, I love this, guys. I love this. Yes, sir.
Once you get the first, like, 3y plus 11, can you just go ahead and put it over the other one?
I guess in a sense you could say that is 3y plus 11, but you still got to get that number right. Because it could be negative 1, it could be whatever. It was whatever that GCF was.
Doing both of them, sort of checking it.
Yeah.
As you're doing it.
Now, there is a shortcut, guys. I'm telling you, there is a shortcut, but you do need to know this method anyway, so might as well learn it now. How many of you understand the process a little bit more than the first one? All right. How many of you anticipate getting it?
It's the second grade.
No. That's the last class, Algebra 1. Okay, let's see here. I'll go over here, 2y squared plus 11y minus 6. All right, the LC does not equal 1. So what method do we use? What do I call that now? The bridge method. Do you guys see the bridge? I mean, does that kind of make sense? I can call it the arc method, the shooting star method. I don't know. It's just the bridge. Bridge them together. What's 2 times negative 6? So I want to get a product of negative 12 that adds up to be what? 11. Okay, so remember, if two numbers multiply to get me negative, one of them has to be positive, one of them has to be negative, but they have to add up to be a positive. So think logically through that. Which number is going to be bigger, the positive or the negative? The positive is. Okay, so 2 factors. I'm going to guess 4 and negative 3. What's 4 plus negative 3? 1. Is that it? No, I got to think of other 2 factors.
6 and negative.
Okay, 6 and negative 2. Those get me that, and they get me 4. Oh, I got closer, but not there. Get me
2,
12 and negative 1. And that gets me 11. They're the winners. They win this one. Yes, got it. You guys will get so much better at this. Some of you will get very quick at it. I'm like, oh, cool. You got it before I thought of it. Okay, what do I do with this trinomial? Break it down. So now it's no longer a 3-term polynomial, but a 4-term. Okay, so does anyone know how to write it? Or have one way to write it? Because there's technically 2. Jack, Harp?
2y squared plus 4y minus 4y minus 6.
Good. By the way, you guys are doing very well so far. Both of you, Justin and Jack, when I asked you to break these apart, you both said 12 and then the variable and -1 and then the variable. That matters. It's not just 12 and -1. It's 12y and -1y. Okay. Factor by grouping. Somebody help me out with the first. I know these boys are getting it. I need a young lady to help me out with this. Yes, I see that hand. Anna Grace. What's the GCF of these 2 terms?
2y.
2y. Okay. Somebody else tell me what's left in the parentheses. Sophie, what would be left in these parentheses?
Y plus 6.
Y plus 6. I'm going to check it. 2y times y, 2y squared. 2y times 6, 12y. Awesome. That works. Second set. I need help from Nelson. What's the GCF of these 2?
-1.
-1. And then what's left in parentheses? Dylan.
Y minus 6.
Okay, let's try it. Y minus 6. Okay, look what happens. What's -1 times y? -1y. Yeah, I got it. What's -1? Oh, there you go. You got me. Beat me to it. And what do you guys notice about these 2 binomials? They're exactly the same. That's what we wanted. And if they aren't exactly the same, force them to be exactly the same. So you got to do it mathematically. All right. What are my 2 binomials?
2y minus 1.
Okay, those 2. You get the common binomial, and then what was left behind.
Did you write the 2y minus 1 first? Or does the y plus 6 mean something?
Only if you tell me why it's allowed.
Some type of property.
Continue.
I don't know.
It's commutative. Yeah.
This right here.
You just switch them around.
How do you get the bottom? I don't get how you get the bottom.
Okay, good question. Ready? Are you good with this?
Yeah.
Okay, I am left with this and this right here. So what do both of these have in common? The y plus 6, right? They both have that y plus 6. So I take that out. I factor it out. And then what was left behind? The 2y and the -1. So 2y minus 1. It's a nice way it comes out that. It's a nice thing that it comes out like that.
So what if they weren't the same?
Make them the same. And technically, if you can't, like there's no possible way you're trying to force things around, technically what is it then? Prime. Good, prime.
So if that was
And there aren't many primes. Sorry.
if it was y plus 7.
Y plus 7, y plus 6. You did everything right. You checked it. There's no way to move it. It's prime.
How do you-
12? Since it's 6.
This right here, 12. Maybe you maybe you had this. You could still factor out a 2 or a -2, and that would have been y plus 6. You just didn't factor it out. So yeah, you got to check it. Is GCF important?
Yes.
Yeah. Is factoring important?
Yes.
Lead coefficient, is that important to know? Yeah, because then the process changes. Sir?
You said force it to
Yeah.
come out. How do you do that?
Yeah. Oh, we're not there yet. Okay, let me do it on, I'm going to give you this next problem to do on your own, and then the following problem we're going to force it if we need to. Okay. Do this one on your own, guys. I don't think I did this one. 11x squared plus 21x minus 2. All right, so try that out. Good luck. Nice. And here's what you can do. And on this quiz, as you notice, I kept it on Monday. I had to, guys, because I'm going to give the test on Friday of the next week. So you're going to have a quiz on Monday, test on Friday. And if I don't, I move it past Martin Luther King Day, and that throws everything off.
Hold on, when's that?
That's not next Monday, but the following Monday. So yeah, it just
We get that off.
And then on President's Day,
Do you not want
we have
that? You wanna
Valentine's
come
Day
in?
and President's Day off, so we get a little bit longer.
4-day weekend on that. But that's sorry, time out. That's in February.
Yeah.
Martin Luther King Jr. is in 2 weeks, well, 1.5, and
We get,
then you get a 4-day weekend
it
coming.
seems like we've got a lot more breaks this year and last year than we used to before.
No, yeah, it does seem like that. Oh, wow, the math on that. Oh, sorry, this is what I want to say. Your quiz will be on Monday. We review on Friday, and I give you Excel to do on your own if you need it. But all of these can be checked, every single one of them. You get your 2 binomials, you're like, I hope those are it. Why don't you do FOIL on them and see if you get the original? Like, you should be able to get it. Sorry, it will come out to the original trinomial if you did it right. Okay, so the answer here, who wants to help me with, who can give me one of the binomial answers? One of them. William?
11x, I mean minus 1.
11x minus 1. That is one of them. What's the other binomial? Matthew? X plus 2. How many, did anyone check it? I know I just gave you like seconds to do it, but anyone check it? Awesome. Okay, that's it. But again, on the quiz, I'm not going to say check them. Make sure you got it right. You just do it if you want to. Great. All right, any questions on that? All right, let's get this last one here that I have planned for today, for this morning. All right, here we go. 3n squared minus 20n plus 12.
So, does a shortcut apply to every single problem? Like, can we do it on every?
It does. It will apply to every single problem, but sometimes even the shortcut on that one, they're like, I can't think of it. And yeah, I can't either. So just do it the bridge method, you'll get it. Okay, but anyway, lead coefficient. I never did this before, but I keep writing lead coefficient is not 1 because on the test, hold on. 1, 2, 3, 4, 5. 6 methods of factoring. And people were like, which one do I use? Well, if the lead coefficient is not 1, which method do we use? The shooting star method. I'm going to call it that. You guys are a bunch of shooting stars. Wait, shooting stars dissolve after a while. Okay, no. You are a bridge from here to high school. How about that?
Sure, how can Drew be a shooting star if he can't shoot?
Oh. I think he can. I've seen it. I've seen it personally. I don't know if he's on a drought. Maybe, no? Yeah. Okay. Oh, my. He needs friends to encourage him and to uplift him and to help him to succeed.
Or the gym might help.
Okay, anyway, we'll leave it there. All right, let's go through this one together. I need it to be a product of positive 36 adds up to be negative 20. So that's a good, it's not automatic for this one. Hold it, don't say it out loud. I want people to think about it. It's not 36 and 1 or negative 36 and positive 1. Not going to work. Oh, sorry, time out. The two numbers have to be either positive to get a positive product, or they both have to be negative. Which one should it be? Because if they add it to be negative 20, they both had to be negative. Okay, so you're thinking through that. But what numbers are they? That's what I need to know. 3 and 12.
2 and 18. Wait, well, not to say it.
2 and 18. Negative 2, negative 18. That gets me negative 20. We found a winner. First try.
Good job.
So please don't give up on these. Mr. A, 1 and 36 didn't work. 6 and 6 didn't work. 3 and 12 didn't work. 4 and 9 didn't work. I give up. 2 and 18 worked. Okay. So then I'm going to rewrite it 3, and I'm going to make this. Okay, I got 3n squared minus 18n minus 2n plus 12. Okay, so I just put those numbers. Notice I reverse them, whatever. Because you could have said negative 18, negative 2. It's the same thing. It's correct. All right, let's factor by grouping. What's the GCF of the first two? 3, n. What's left? N minus 6. So far, so good? Get that? 3n times n, 3n squared. 3n times negative 6, negative 18n. Whew. Okay, I'm good with that. What's the GCF of those two? 2. Positive 2, right? Positive 2. What am I left with? Negative n plus 6. Yeah, wait. No. What happened? Are these exactly the same?
No.
Exactly the same.
Just switch this.
Okay, but if you switch the sign, something, what changes? I have to ask.
Yeah, how do you get plus 2?
Plus,
It's -2.
because there's positive 12, you can't multiply it.
If you
No, no,
multiply,
I got plus 2 and minus 6.
Yeah.
Well, if you get,
Oh,
I got minus 2 and minus 6.
Wait, what? What?
I got positive and minus 6.
Okay, if you took out the GCF, remember one's negative, one's positive. You should take out a positive, right? But this is what you're left with. But if you took out a negative 2, right? If you took out a negative 2, this becomes positive, and what happens to that? It becomes negative. Now it works.
That's what I got.
Yeah, and so some of you got it first time, great. Some of you did not get it first time, fine. Just change it up.
Mister, I thought you only take out a negative if they're both negative.
Yeah, that's when finding the GCF. But remember on this part, when we took out that positive, we were left with negative and a plus.
Is that what forcing it means?
That's what forcing it means. So did we force it and still keep it the same? Like we didn't just, yeah, switch signs and make sure you switch them in the right spots. Okay, so what's your GCF of these two? N minus 6. What's left? 3n minus 2. And that's how you get it. So you can move things around as long as you do it mathematically according to those properties.
Wait, someone's already asked this, but can you do it in like the opposite way? 3n minus 2, and then n minus 6.
You tell me why.
Yeah.
Yeah, there you go. All right.